keen on converting waste to material. They call it the circular economy, and that's continuing to this day. The project was conceived back in 2012, and it was through an EU call, turning waste material into other resources. This is a big part of the EU. The importance of the materials from the Plascarb project is that it fits one of the criteria of the EU. The EU have graphite as one of the 14 materials which is critical for sustainability within the EU. Plascarb material is important because it gives another opportunity to develop this material going forward within in this market, which is growing substantially, and the hydrogen for opportunities in other markets such as hydrogen fuel cells.
Food is a very valuable resource, yet in the EU alone there's about 88 million tons of food waste that gets generated annually.
We produce a lot of material, it's not being utilised. We have lots of scrap, so lots of food doesn't get eaten. There's lots of food that goes out of date, and there needs a real sustainable way of dealing with this issue. Food banks are great, and that should be a primary use, to reuse the food where we can, but beyond that we need to capture that food and stop it going to landfill. Collections is the biggest problem. You're talking over hundreds of thousands of pounds just for one vehicle to go around all the different houses to collect their food waste. Okay, traditional AD plants are putting either gas into the network, or they're putting energy into the network, which are still very good things to do with the material. In this case, we are performing a better duty of care. We are no longer putting things into landfill. That's the original case. The next case up, which is our traditional AD, is making energy, renewable energy. But with this here, we're actually going further up the chain again, and we're creating something new, a new product, so it has a new life altogether.
Our unique production process starts with a gas, like methane, the classic greenhouse gas. Because we want to achieve an all-carbon product, we have to crack it first. We do so by the usage of high-powered industrial microwaves. The produced microwaves are then used to generate plasma, which cracks the gas. The high energy of the microwave causes the gas atoms to break apart, and that's how we obtain atomic carbon, which is self-assembling in the latter stages of our reactor process to form nanoforms, such as graphene and graphitic nanoparticles. This is 1 gram sample of Plascarbon, which is the product of the Plascarb project. As you can see, it's a low-density fly powder.
Plascarbon, it's a carbon material of graphitic nature. It's of nanometer size, 50 to 100 nanometer size. 1 nanometer is 10 to minus 9 meters, so you can imagine that it's composed of very small particles. It's of 20 to 30 graphene layers.
The Plascarbon is comparable with high-quality carbon black in the market.
Carbon black comes from the petrol industry, and we're trying to change, to go into a newer era without petrol. In plenty of industrial applications, you need to have a conducting coating that can be on an airplane, the body of an airplane, in the gasoline line of a car. You need to have plastic which is conductive so that you avoid sparks.
The advantage of the Plascarbon is due to its small size, we can use this small graphitic Plascarbon as inkjet printable.
The second thing is supercapacitor. Supercapacitor is a way to store energy, you know. And I think it's really wonderful that starting from food waste, we can make little foldable supercapacitors on a piece of paper, you know, that you can store electricity with that. We found that it can actually be useful in the fuel cell area. And that's very important because it's a way, again, to store and provide energy.
We're using a method called life cycle assessment, or LCA, to quantify the environmental impacts of the Plascarb project.
The currently used technologies which Plascarb has to compete with is biogas to electricity on the one hand side, and on the other hand side you can also landfill it, the food waste.
For example, if you have a less carbon intensive electricity grid mix, so in this environment, Plascarb is very beneficial.
It can be used in any methane producing plant. Anywhere producing methane, this technology can be used. Every indication from the work we've been doing in the latter work packages indicates not only is it viable, it's a very good return on money.